Hi everyone. In this video, we will learn how to calculate the productivity of a process. In problem 1, we are required to calculate the productivity for an operation where we have 3 employees who process 600 insurance policies in a week. They work for 8 hours per day and they work for 5 days per week. We are required to calculate the productivity of this process, and we are also required to write units in our answer. We know that the information available about the output is that the employees process 600 policies. As far as input is concerned, we know that we have 3 employees who work for 8 hours per day for 5 days. We multiply these values and our input value is 120 hours. In order to calculate the productivity, we use the formula for the productivity, which is output over input. Our output value is 600 and our input value is 120 hours. We calculate the value of productivity as 5 policies per hour, and this is how you calculate the productivity of a process. In problem 2, we have the information of Jiffy Lube and the company wants to compare productivity in 2 locations. At location A, we have the information about the number of oil changes, which is 85 oil changes done by 5 employees working on 8 hours shift. We are required to calculate the labor productivity at location A. The output value is 85 oil change, and we have the input in the form of 5 employees who work for 8 hours per shift. So the input will be equal to 40 hours, and we calculate the productivity by using the information about output and input in the productivity formula, and our answer is 2.125 oil change per hour. Problem 3 states that Jiffy Lube wants to compare productivity at location B. Location B completes 126 oil changes done by 4 employees working an 8-hour shift using 3 stalls. Each oil change costs $25 and employees earn $10 per hour. Each stall costs $30 per day and all other costs are $20 a day. We are required to calculate the multi-factor productivity at location B. We know the formula for the productivity calculation is output over input. We calculate the output by multiplying number of oil changes with the cost of one oil change, which is $25. So the output is $3,150. In order to calculate the input, we need to consider employee cost, stalls cost, and all other costs. We have the information of employee cost, which is there are 4 employees who work for 8 hours in a shift and they are paid for $10 per hour. In stalls cost, we have 3 stalls and the cost of each stall is $30. And there are other costs that amount to $20. Now when we calculate the input, the value is $430. Now we have the value of output and input. We plug in these values in the productivity formula and our answer is 7.32. Problem 4 states that a professor can grade a quiz in 2 minutes. Over the course of an academic year, he has 6 sections of a course with an average of 25 students with 10 quizzes in each section. If he is paid $40 an hour, how much is his annual quiz grading labor cost to the university? In order to calculate the labor cost, first we need to look at the number of total quizzes. We know that there are 6 sections of that course and there are 25 students in each class and there are 10 quizzes. When we multiply these values, we calculate the total number of quizzes. The value for total number of quizzes is 1500. We also know that it takes 2 minutes to complete one quiz. So for 1500 quizzes, it will take 3000 minutes. We divide 3000 by 60 and we convert this value into number of hours. that is equal to 50 hours. We know that the professor is paid $40 an hour. So we can calculate the labor cost by multiplying $40 per hour with the number of hours, which is 50. And our answer is $2,000. In problem 5, you are required to calculate the productivity of an operation where a team of workers make 400 units of a product. Now each product is sold for $10 each. The accounting department reports that for this job, the actual cost is $400 for labor, $1,000 for materials, and $300 for overhead. Now, in order to calculate the productivity, which is called multi-factor productivity because we have multiple inputs, the formula is value of output divided by labor cost, material cost, plus overhead cost. First, we calculate the value of output. We know that there are 400 units and each unit can be sold for $10. So the value of output is $4,000. The input value is the sum of labor cost, material cost, and overhead cost. We have the information for labor cost, material cost, and overhead cost, and that is equal to $1,700. Now we plug in the values in multi-factor productivity formula and our answer is 2.35. In problem 6, we have the information for the weekly output and input for a fabrication process. Output is 400 units with a standard selling price of $100 per unit. For the week, the labor cost is 10 workers who work at 40 hours for the week and workers are paid $15 per hour. Total material cost for 400 units are $5,000. Weekly overhead is charged at the rate of 1.5 times the labor cost. So we are required to calculate the multi-factor productivity for the week. We know the formula for the multi-factor productivity, which is value of the output divided by the sum of labor cost, materials cost, and overhead cost. The value of the output can be calculated by multiplying the number of units with the cost of each unit. So we have the value of output as $40,000. The value of input is the sum of labor cost, material cost, and overhead cost. In this case, we have 10 workers who work for 40 hours and workers are paid $15 per hour. So this is our labor cost. We multiply these values and get our labor cost. The material cost is $5,000 and the overhead cost is 1.5 times the labor cost. Now we simplify the calculations and we have the labor cost as $6,000. We have the material cost as $5,000 and the overhead cost is 1.5 times $6,000, which is equal to $9,000. So the overall value for the input is $20,000. Now we calculate the multi-factor productivity by dividing the output by input and our answer is 2. In problem 7, we have the information about the Brexit University where the student tuition is $200 per semester credit hour. The state supplements school revenue by $100 per semester credit hour. Average class size for a typical 3 credit course is 75 students. Labor costs are $6,500 per class. Material costs are $25 per student per class and overhead costs are $30,000 per class. We are required to calculate the multi-factor productivity for the university. First, we calculate the output. The output is calculated as follows. We know that we have 75 students per class. We multiply that value with 3. 3 is the credit hour per student. And we know that the cost paid by the state is $100 and the cost paid by the student is $200 per credit hour. So in that case, our output value is $67,500. In case of input, we have the information for the labor cost, material cost, and overhead cost. Labor cost is 6,500. This is given in the problem statement. Overhead cost is $30,000. We calculate the material cost by multiplying $25 per student with the number of students, which is 75 in a given class. So we have the value of input as 38,375 per class. We plug in that value in the multi-factor productivity formula and we have our answer for multi-factor productivity as 1.76. In problem 8, we have the information about Alisa's custom cakes. Alisa sells 5 birthday, 2 wedding and 3 specialty cakes each month for $50, $150 and $100 each respectively. The cost of labor is $50 per hour including benefits. It takes 90 minutes to produce a birthday cake, 240 minutes to produce a wedding cake, and 60 minutes to produce a specialty cake. Alisa's current multi-factor productivity is given as 1.25. You are required to use this multi-factor productivity ratio and calculate the average cost of the cakes produced. So this is how we address this problem. We are given the information of multi-factor productivity ratio. So first we calculate the cost of each type of cake. We know that Alisa makes 5 birthday cakes. So the cost of birthday cakes is $250. For wedding cakes, we have the cost as $150 per cake and there are 2 wedding cakes. So it means the total cost is $300. There are also 3 specialty cakes. So the total cost for specialty cakes will be $300. We can calculate the output by adding the values for birthday cakes, wedding cakes and specialty cakes. We add these values and our output is $850. Now we know that multi-factor productivity is equal to output over input. We know that we have the value of multi-factor productivity as 1.25. We know the value of our output. We just calculated the value of output, that is equal to $850. We are required to calculate the value of input, which we call X in this case. Plugging in the values, we have the information for the value of X as $680. Now we are required to calculate the average cost of the cakes. This is the total cost for all the cakes and we can calculate the average cost per cake as follows. The total cost is $680 for 10 cakes. We divide it by 10 and we get the cost for one cake, which is $68. In problem 9, we are given this information about a manufacturing process that requires 12 minutes of labor to make 10 units of a product. We are required to analyze the following scenarios and identify which of the following actions will increase the productivity. We are given these 4 scenarios. So let's analyze these scenarios. The first one is increase labor by 10 units of production. So if we increase labor, then it means we are increasing our input, which is counterproductive. So it will reduce the productivity. The second option is we decrease labor per 10 units of production. In this case, since we are decreasing the input, so it will increase the productivity. So this is a right approach. The third one is we increase the number of units per 10 minutes of labor. So for every 10 minutes of labor input, we increase the number of units. That means we are producing more units and we are increasing our productivity. This would also increase productivity because more units are produced in the same amount of time. And the fourth option is decrease number of units per 12 minutes of labor. So this will also decrease the productivity because fewer units will be produced in the same labor time. So to summarize, option 2 and option 3 will increase the productivity. In problem 10, we have the information of an assembly operation at a furniture factory. we are required to calculate the labor productivity of this operation. We know that the output of this process is 450 chairs. The input can be calculated by multiplying number of employees with the number of days, and we have 6 employees who work for 5 days a week, so that will be equal to 30. And finally, we can calculate the labor productivity by dividing output by input. We have the output value of 450. We divide 450 by 30 and our answer is 15 chairs per employee per day. In problem 11, we have the information of a company that manufactures electrical assemblies. The current process uses 10 workers and produces 200 units per hour. You are considering changing the process with a new assembly method that increase output to 300 units per hour, but it will require 14 workers. We have this information summarized in this table. The cost of material per hour for the new process will be 150 and the workers are paid at a rate of $10 per hour and the overhead is charged at 140% or 1.4 times the labor cost. Finished switches will sell for $20 per unit. We are required to calculate the multi-factor productivity for the new process. So this is the new process information. So how we address this problem? First, we look at the input. Input has 3 factors. The first one is the labor cost, second one is the material cost, and the third one is the overhead cost. So we calculate the input by adding labor cost, which is 140, material cost is 150, and overhead cost is 1.4 times the labor cost, which is 1.4 into 140, and the total value of the input is $486. The output value is $6,000 since we produce 300 units and each unit can be sold for $20. So the output value is $6,000. We have the value for output and input. Now we can plug in these values in multi-factor productivity formula and we have the answer as 12.34. In problem 12, we have the information about a ship manufacturing company. It takes 26 weeks with 500 workers to build a small tanker. Material costs are $32 million and overhead costs are $2 million. Workers cost $40 per hour including benefits and they work for 40 hours per week. The ship sells for $75 million. We are required to calculate the multi-factor productivity ratio. So this is how we calculate the multi-factor productivity ratio. We have the input, which is equal to labor cost plus material cost plus overhead cost. The labor cost is calculated as follows. We have 500 workers who work for 40 hours per week and are paid for $40 per hour and they work for 26 weeks. So the labor cost is equal to 20.8 million. The material cost is given in the problem statement, which is $32 million. And the overhead cost is $2 million given in the problem statement. We calculate the input by adding these values of 20.8 million, 32 million and 2 million. The total input is $54.8 million. We know that the output is equal to the value of the ship, which is $75 million. We use the multi-factor productivity formula and divide output by input. The output value is 75 million and the input value is 54.8 million. And our multi-factor productivity is 1.368. And this is how we calculate the productivity of a process. Thank you for watching and see you in the next video.